Love it.
I'm only using
Something serious. Okay.
okay, so are we ready? Are we ready?
Everybody's ready.
Yes, so can we start? Can we start now?
Start now.
It's life already.
Is it beginners?
It's not supposed
Start.
Just
Start now.
Alright, good afternoon, class.
Afternoon.
Good afternoon, class.
Good afternoon.
Alright. So we are going to be starting with physics Newton's equations of motion. It's one of the very basic things in physics which we are going to look at. All right, and on the strength of this, I would love us to be very attentive, okay, because we are going to be going through a very interesting journey, okay, on this Newton's equations of motion. So there are three Newton's equations of motion. So what we're going to be basically doing today is seeing how those equations of is derived. Okay, and on the strength of that, I will be welcoming questions if you have any. So we proceed. The first equation of motion, which says that V equals to U plus AT, as you all know, is from the fact that basically speaking, acceleration, which we know is change in velocity all over time, right? Change in velocity over time. When I'm talking about change in velocity, I'm referring to the difference between the final velocity and the initial velocity. So, what does this mean? Capital letter V is the final velocity, and U is initial velocity. V and U rather. So if I'm looking at change in velocity is simply the final velocity minus the initial velocity. So that means acceleration will be given as V minus U all over T. The V minus U there that you're seeing in the numerator is the um, change in velocity. And from here, I would simply cross multiply. When I cross multiply, what I'm going to have is that AT is equals to V minus U. AT is equals to V minus U. If AT is equals to V minus U, make V the subject of formula. Simply take minus U to the left hand side. What I will have is that AT plus U is equals to V. AT plus U equals to V can also be written as V is equals to U plus AT. So obvious and simple, we have gotten our first equation of motion. Our first equation of motion, which says that V is equals to U plus AT. Having seen that, we move quickly to the second equation of motion. So, how do we look at the second equation of motion? The second equation of motion is quite simple, which is what we're going to go to right now. You can just keep this somewhere, all right? That equation 1, V equals to U plus AT. That's equation 1. Let's move to the second equation. In the second equation of motion, it's important that we note that distance covered by a uniformly accelerated motion, that is distance s covered by a uniformly accelerated motion, is given as average velocity times time. Average velocity times time. And on the strength of that, any question?
No, sir.
What is average velocity? Average velocity, you can call it V bar. V bar is telling you that you're finding the mean value of the velocity. Average velocity is given as initial velocity plus final velocity divided by 2. Initial velocity plus final velocity divided by 2. Remember, we've already spoken about what U stands for and what V stands for. So this is my expression for average velocity. I add the two velocities and divide it by 2. The 2 is to find the average, all right? That simply means that if my V bar is given as U plus V all over 2, from equation 1, don't forget equation 1, that says that V is equal to U plus AT. So from equation 1, what am I going to do in equation 1? If that is my V bar, and equation 1 gives me that V is equals to U plus AT, all right? The next thing I will simply have to do is that I will substitute the value of V, which is my equation 1, into my V bar. It's simple, not confusing at all. So V bar equals to U plus V all over 2. So in place of V, which is the expression we got in equation 1, we would simply say that this becomes what? U plus, so in place of V, we'll just say U plus AT all over 2. U plus AT all over 2. So what's the implication of this? The implication of this is that V bar will give me U plus U, that's 2U, plus AT all over 2. If you look at this closely and critically, you discover that V bar becomes 2U all over 2 plus AT all over 2. Of course, 2U all over 2, that cancels out. And what you now have left is that V bar equals to U plus AT over 2 is something as half AT. AT over 2 is something as half AT. All right. So if we have agreed on this point, the next thing we're going to do is that we will substitute the value for V bar, which is average velocity, into our expression for distance. So I can give you 1, 2, 3, or 4 seconds to just catch up with the screen from where we are, because I would be continuing from this expression, this equation rather. Yeah. So from there, let's make the substitute. Making the substitute, we now have that our average velocity, this is V bar times time, and our distance is S. I believe you still remember what V bar is, plus half AT times T, S for distance. Moving from there, this means that T will multiply everything in the bracket. And when that happens, T times U is UT, T times half AT is half AT squared. At that point, you can quickly see that we have arrived at Newton's second law of motion, equation rather. So we now say that our second equation of motion is S equals to ut plus half at squared. That's equation 2. All right. So can you probably check this? So you can like set. All right. So from there, we move ahead to the third equation of motion. So what's the first thing we do in finding the third equation? It's simple. From the third equation, we are still going to be using v equals to u plus at, which is still our first equation. Yes. And don't also forget that since S is equals to ut plus half at squared, these are very important equations we are going to make use of in arriving at the third equation. The first thing I will do now is that in equation 1, I'm just going to square both sides. Squaring both sides, square v, I will have v squared, and then square u plus at. If I square this, what I'm going to have would be u squared plus 2u at plus a squared t squared. So from there, having squared both sides, we will discover something. From this point, I will do a little factorization, and the factorization I will do is that I would factorize what I have here. If I factorize this, I'm going to have 2u into, not 2u, 2a, that's the highest common factor there. 2a into u plus a t squared. And looking at that critically, you would agree with me that, look at that again. If you factorize this, if I open this bracket, I should have what is up here. If I open this bracket, I should have what is up here. 2a times uat. Okay. 2a times uat is 2uat. 2a times at squared is 2at squared. For us to have a squared t squared, this has to be half at squared. Yes. Such that 2a times half at squared will just give us a squared t squared. So we are good to go now. Moving forward from there, we will have that u squared plus 2a ut 2a times ut is 2uat into ut plus half at squared. So ut plus half at squared is s. So v squared finally is u squared plus 2a. What is inside there is s. So we've gotten to the second equation of motion. Stay tuned for the third equation. Thank you so much for your time.